Hello there and welcome to this lesson today where we are going to be looking at searches and sorts. So what I want you to do is copy down the title, searching and sorting algorithms, those keywords and their meanings into your book, and then we'll get ready for the exam questions. So give the video a quick pause and then we will get cracking. So here is your exam question today. Fiona is a software engineer. She's creating a new version of a computer game she released 3 years ago. Fiona releases her game under a proprietary license. Explain why proprietary license is a more appropriate choice than open source. It's worth 2 marks. You've got 2 minutes. Remember, you don't need to fill up all that space. Remember, that's one of the exam top tips we looked at previously. So give the video a quick pause, answer the question, then we'll have a look at marks, and then we'll crack on with today's lesson. So this is where we can pick up your marks. We can talk about selling something for free. It protects a source code. It can't be copyright modified, redistributed. What we're wanting to get from this is the reasons why, the positive reasons, the advantages for using it, for using proprietary software compared to open source. Okay, that's what we're looking for here. If you've got any questions, if you're not sure about it, drop me them over on an email and I can have a look at them and give you some feedback. So now we've got that done, make sure you've written down in green pen any answers that you didn't get written down, or if you didn't get 2 out of 2, make sure you've got an answer there for which is worth 2 out of 2, and then we'll get going. So give the video a quick pause and we'll get going. So what we are going to be looking at today, to begin with, we are going to be looking at some searches. So if we have got this top image up here, if we are searching for the number 23 in a 10 element array, we're going to look first of all at the middle value, which in this case is 16. Because we know that 23 is greater than 16, we're going to eliminate the first half and then we're going to go into the middle of the new group here, 56, and we know that 56 is greater than 23, so we're going to look at this low half here, and then here we go, 23, fantastic, we found it. So with a binary search, it has to be in order. You can't have things muddled up all over the place because you then can't do the comparisons between less than and greater than. So we want to be making sure that we've got everything in the right order, the right value, and then we keep cutting it in half, cutting it in half, cutting it in half until we found our result. By comparison, we have got here the linear search. And again, we're going to look for the same number, 23. We've got exactly the same array, the list of numbers down here as well. Is this number 23? No, it's not. Is this 23? No, it's not. Is this? Is this? Is this? Fantastic, we found it. Happy days. Number 23. Good times, we found it. So now we found number 23. It's taken more steps than the binary search. And if we've only got a small set of data, like say 5 pieces of data, a linear search is probably the quickest way to go. So for example, if you've got a new pack of football stickers, 6 stickers in a pack, it'll be quicker just to do a linear search to go through them all to find the one that we've got. Fantastic, I found Peter Schmeichel, Man United goalie, happy days. If we've got 200 football stickers and we know they're all in order, at which point the binary search is going to be much more helpful because it cuts down the data. We can get through the steps really quickly and easily. In this example here, it took us 3 cuts to then find what we needed in our binary search, whereas with the linear search, if we found it on the 6th attempt, if we were looking for the number 91, still the binary search would have been quicker. The only way this would have been quicker is if we were looking for the number 2 or the number 5, or maybe even possibly now not even the number 8. So if it was 2 or 5, we knew it was the first 2 values, it would have been quicker. But in this case, we want to be making sure we're using the right sort of search. So what I want you to do, based on the all, most, and some, is first make sure you've written almost or some in your book, and then you're going to answer those 3 sets of questions there, depending if you're going for the all, the most, or for the sum. When we're looking at the sum, we're talking about efficiency and why we want to be efficient. Okay, so give the video a quick pause. You're going to have 10 minutes to do this in, so give the video a quick pause, and then we will move on. So what we're going to do right now is we're going to look at bubble sorts and merge sorts. When we're looking at bubble sorts, firstly on the left hand side, we are going to compare 2 values. So this value here, -2 and 0, yep, they're in the right order, fantastic. Then we move down here, 0 and -9. Now that's not the right order because -9 is less than 0. So what do? We switch it over and then we look again, is -2, -9, yep, that's right, that's right, that's right, and that's right. Fantastic, it's all in the right order. So the bubble sort, we're comparing the 2 values one at a time, and then we're reorganizing them and then starting again if they are not in the right order. So then we can get everything done nice and happily. On the merge sort over here, we've got up here a group of unsorted, a list of unsorted data. And what we do is we cut it in half. So we've got 6, 5, 12, 10, 9, 1. So we've taken this half and we put it over here. And we've taken this half, we put it over here. And then we're going to cut them down again. So we're going to move 6 just by itself. Then we've got 5 and 12 together because we can't cut 3 evenly straight away. And then we've got 10 over here, 9 and 1 over here because we can't cut 3 evenly. At which point then we have now separated them into their individual pieces of data. So we've gone from an array, a list of 6 pieces of information up here. We've now got 6 different variables, 6 different pieces of data all individually here. And then what do? We merge them together. So 6 can't really merge with anything. 5 and 12 are already in the right order. 10 can't merge anything, but 9 and 1 are not in the right order. So when we merge, we put them into the right order. So 1 and 9 switch positions, so now they're in the right order. And again, we then take these 3 pieces of data on the next level and we merge them in. So now 6, 5, 12, that's not in the right order, but 5, 6, 12, that is the right order. And then over here, 10, 1, 9, that's not the right order, but 1, 9, 10, hang on a sec, that is the right order. So now we've got these 3 mini lists, which we're then going to merge together. And then when we do this merge down here, we're then reorganizing them all happily quite there. And then we've got the insertion sort here. So we're looking at here the value number 1, we're moving the value number 1 up, and then we're moving them all over, and then we're going to put them back down. So when we're doing an insertion sort, so here we can see the number 8, 1, 3, 5, 6, 8, that's the right order. 1, 3, 5, 6, 8, 7, whoa, hang on a sec, that's not the right order. We're going to move it up, and then we're going to insert it in the right place. Then we're going to see the number 2. Hang on a sec, this isn't right. You can guess what's going to happen now. They're all going to move over, move over, move over, and finally move over. And 2 is going to slot down where it needs to go. And then finally, the number 4, yeah, you know what's going to happen. This isn't in the right order, so we're going to move them over, move them over, move them over, move them over, and 4 can slot in quite nice and happily. Insertion sort complete. Happy days. We've got a nice ordered list here. So, task number 2, this is what we need to get done now, is if we're going for almost or some, what I want you to do is quite nice and easily complete those tasks you see there. Again, I'm going to give you 10 minutes on this. So give the video a quick pause and then I'll tell you what I want you to be doing in the last part of today's lesson. So in today's lesson, what I want you to do now, I want you to be completing 2 tasks. Firstly, in your books, I want you to create a spider diagram. And on that spider diagram, I want you to write down all the information about what we've got from the different sorts of sorts and searches which we've looked at today. I want you to talk to me about if they need to be ordered or unordered, how they work, how they're going to operate. So you've got a nice, quick, easy thing to look at and you can see and understand everything. So you've got a nice little revision piece of information there. And then what I want you to do is either for sorts or for searches, I want you to go onto the computers and I want you to create me a poster which is suitable for Year 7 students for how to use either A, different sorts, or B, different searches. So that's what you need to get done. So once you've created your spider diagram to show all the information we've looked at today, you're going to create a poster on the computers with either A, an information about all the sorts, or B, for all the searches. It needs to be suitable for a Year 7 student, and I'm expecting that all to be completed and emailed over to me by the end of your lesson today. If you've got any questions, I'm on my email all lesson, so feel free to get in touch, and I will see you in your next lesson. Bye-bye.